Question 30 from the homework is actually a challenging question. Number one, they did not draw in the lone pair electrons on oxygen, which makes that a little bit harder for you. And then number two, we're forming a pi bond in an unusual way, so in a way that we didn't talk about in class. So it's asking what type of orbital overlap is responsible for the pi bond between phosphorus and oxygen atoms in the molecule below. And to answer that question, we need to figure out the hybridization of both phosphorus and oxygen. So oxygen, to answer that question, oxygen, right, we count the electron domains, lone pair, phosphorus, oxygen, double bond. So oxygen is sp2 hybridized, right? So I have my s orbital and I have my 3 p orbitals. I have the electrons. I've got 6 electrons assigned. 1, 2, 1, 2, 3, and 4. When I go and hybridize those orbitals, right, I'm going to go and I'm going to take 3 of those orbitals. So I take 3 of those orbitals, hybridize them together, and out of that I'm going to get 3 hybrid orbitals that are sp2 and 1 p orbital that's unhybridized. I want to reassign those electrons, right? I reassign those electrons and I get 1, 2, 3, 4, 5, and 6. So now looking at that oxygen, right, I have 2 lone pair electrons that are in my hybrid sp2 orbital. I have 1 electron in my sp2 orbital. I'm going to make my sigma bond with that. And I have 1 electron in my p orbital that is unhybridized. Now we're going to get to our phosphorus, right? Phosphorus is 4 electron domains, right? 1, 2, 3, 4 electron domains. Because phosphorus has 4 electron domains, sp3 hybridized. And so what that means is I'm going to take, right, all of my s and p orbitals, I'm going to blend those together to make 4 hybrid sp3 orbitals. So I blend these orbitals together right here. And my 6 electrons, right, I'm going to take my 6 electrons. Well, I'll blend these orbitals together first. Here's my s orbital, here's my p orbital. I blend these together and I'm going to get 4 orbitals that are all sp3. And I'm going to pull down 1 of my d orbitals. So I have 5 electrons in phosphorus, right? 5 electrons that I have to assign. 1, 2, 3, 4, and 5. And now I can take a look at the phosphorus, right? The phosphorus that I have. Here's where I'm going to form my sigma bonds. I'm going to form my sigma bonds with fluorine. 1, 2, 3 sigma bonds with fluorine, right? Fluorine will donate 1 electron, will share 1 electron. 3 different fluorines, those are those bonds used. Here's my sigma bond with oxygen, right? So the 1 electron here is going to pair up and share with this, overlap with this orbital here. That's my sigma bond. And I've got 1 electron in my d orbital. And so the orbital overlap for my pi bond will be between the p orbital on oxygen is going to overlap with the d orbital on phosphorus. And that's because we already have in the sigma bond, right, if I were to draw phosphorus and I were to draw oxygen, right, oxygen is sp2 hybridized. So here are my sp2 hybrid orbitals that are 120 degrees apart. Oxygen is taken care of. Here are my lone pair electrons. I have 1 electron here in these sp2 hybrid orbitals. And I have my 1 unhybridized p orbital. Now phosphorus is tetrahedral geometry, so to draw phosphorus, because it's sp3 hybridized, right, there's 1, There's one here, and one here. Not the best drawing, but we get the idea of here's my electron from phosphorus, my electron from phosphorus, my electron from phosphorus, my other electron from phosphorus. So there's my sigma bond between phosphorus and oxygen, right? And now fluorine's going to come in, fluorine comes in, fluorine comes in. To make that pi bond, right, to make that pi bond, we need side-to-side orbital overlap. And here's where I made a mistake in my drawing, because now I have to draw a d orbital. And the d orbitals, if you remember, kind of look like a clover leaf. So here's my d orbital, right? They're going to overlap above and below the plane of my bond axis, right? My bond axis is right between the phosphorus and the oxygen. Here's my bond axis. I already have electron density there, so I can't put any more electron density there. The pi bond, right? The pi bond has to put the electron density somewhere else, and that's why we need either two parallel p orbitals to overlap above and below the plane, or we can use a p orbital and a d orbital in the case of phosphorus. So I mentioned that when I was talking about pi bonds, but we didn't go over an example of that. So that's what makes this question tricky.